How are you? We hope you are doing well. Stay safe and keep health there during pandemic. And I would like to congratulate to every one of you because amongst a million people out there, you still choose join with our webinar today. So we hope we give you a positive feedback. And Mr. Nicola there, Mr. Gailan from Australia, from Congo, thank you for coming and join with us. Yeah. And topic for webinar today is Q type on Mikrotik, right? Yes,
Yeah.
Ahmad?
Yes, correct.
Okay. So, okay, during webinar, if you have any questions, you can ask questions, unmute yourself, or maybe you can put on chat box message on there. Give it the slide.
Yeah, slide is okay, hopefully.
Slide is okay. So, should we begin?
Yeah, sure.
Okay, so let's begin. Thank you and enjoy the webinar.
Right, thank you, admin. Okay, let's continue with our discussion tonight. So tonight we'll be talking about the Q type on Mikrotiks. This topic actually is not for beginner. At least you need to have some experience on Mikrotik before you attend this webinar. Yeah. So the agenda that topics that will be discussed tonight will be QoS, queuing theory, and Q types. So the main topics is Q types, but I'll be talking about several prerequisite topics just for review to get you more understanding about the Q type itself. Okay. I'm sorry. Introduction about ourselves. We are GLC based in Bandung in Indonesia. Our area is IT and training, IT consulting and training. We are partnered for Mikrotik, Ubiquiti, Linux, and we also have our own products named GLC Billing or GLC Radius Manager. We also do regular events like we are doing tonight. That is the webinar. My name is Achmad Mardiansyah, and I'm based in Bandung. Linux user, Mikrotik user, Ubiquiti user, Cisco user, many users. Also doing teaching, teaching IT, mainly networking and networking operating system, actually system administration, mostly Linux based, and some programmings and programmings, database, like IT solutions. Guys, if you have LinkedIn, this is my LinkedIn profile. Um, you can search my name, and then hopefully we can connect on LinkedIn. So I would like to connect with you guys on LinkedIn. Hopefully it will open new opportunity in the future. About past experience this year, mostly we are doing related things related to networking, like network support and integrations. Network support like migration from bridge network to routed network, network expansion, network planning, integration with IoT, integration with billing, with the radius, and then others. Places are different, in located differently. We were doing project in Indonesia, in other countries as well, in UK, in the Africa, Australia as well. About the webinar itself, it is started in 2010. Talking about some various topics, but mainly currently the topics are related to networking, system administration, and programming. You are welcome if you want to share something here. No problem. We will save a slot for you. About yourself, thank you very much for introducing yourself here. I can see we have more than um, 30 participants. Oh, 40 now. Oh, okay. That's quite a lot. And coming from various countries, various continents. The far east is from maybe from Australia. The far west is from Africa, and perhaps from Europe. Uh, yeah. Um, but thank you very much for coming. Really appreciate that. And as I said, this topic is not for a beginner. So I would like to assume you already have some understanding of some topics below, like encapsulations, the difference between TCP and UDP, understanding TCP sliding windows mechanism. We assume you already know how to use packet analyzer, like the Wireshark, understand how the router works, and then how the packet marking works. Oops, why is it like this? Okay, never mind. Can continue. So first is encapsulation. So encapsulation is a process for wrapping a data with another header. So we started from the data, and then on layer 4 we have we have a encapsulation name segment or datagram, and after that on layer 3 we have packets. Okay, so the result of encapsulation is these terms, either segment, you just only have this options. So segment or datagram. Segment if you use TCP, datagram if you use UDP, and then you have packets and then frame. Simple as that. Um, Regarding with the header, so as we know, header is the data that is added into the previous data. Okay, we can say we can say it's like encapsulation or enveloping. So when you send a mail, this is a real mail, okay, not email. So when you write something on mail, and then that's your data, and then you put the data inside the envelope. So you can think header is like the envelope which is wrapping the data. So that's how encapsulation works. And here, this is the layer 4 header. Okay, this header is two header on the slide here. First, you need to know the difference between them. Which one is TCP, which one is UDP. And then on layer 3, this is the header looks like. Okay, we have IPv4, IPv6. Okay, those are different things. And then this is a header for layer 2, especially for Ethernet technology. What about Wi-Fi? Well, Wi-Fi is not here, but you can find how the Wi-Fi header looks like in the internet. Okay, so the thing is when you take a look closer, when the way we send the data through the internet, you can see there is a big overhead on encapsulation process. So you are sending data hello, but actually the one that is sent from your device is not only hello. Okay, you type on WhatsApp hello, but actually after the WhatsApp sent through the Wi-Fi or a GSM, it's not only hello. There are many information needs to be attached on that data in order to make sure that the packets arrive at the destination. Okay, so here we talk about the layer 4 flow control. So on layer 4 we have two main protocols. There are TCP and UDP. UDP is very simple. As you can see, the previous slide, UDP is there is no much mechanism you can only have a port number and then the checksums. It's very simple. But TCP has lots of mechanism, and one of them is the flow control. The way we control the data send over the TCP is by using window size here. So as you can see, when you see the protocol analyzer, this is the TCP, okay? And then in the TCP, you have several flags. And then one of the flags is the window size here. And then the window size can be considered as a step of original size. So as you can see, the way we send the data here, we can do a scaling factor, where we can uh, achieve a data efficiency for data transfer. So for example, if the window size here is 1, and then the way you send is you send one segment and then you wait for acknowledgement. If the acknowledgement okay, and then you send again, acknowledgement, send again, okay? This is the window size of 1. The way but as you can see, this is the time slot, okay, from here to here. Okay, let's say 10 seconds. So in 10 seconds, you just only send 1, 2, 3 packets, 3 segments. But what if you increase the window size? So instead of 1, you're sending 4 at the same time here. So you're sending 4, yeah, and then you receive the acknowledgements, send another 4, send another 4. This is how the TCP send the data, okay, to increase the efficiency of the data. So that's why, yeah, in TCP we can, yeah, there is a mechanism to increase the window size from 1 until to whatever the algorithm on your operating system. So the higher window size, the more data that is sent at the same time. Yeah. So what if the data missing? So for example, we are sending 4, but one of the segment is gone. So what we'll do is we are sending the retransmit the missing packets, and then after that, when the packets arrive at the destination, there will be um, a mechanism for reassembly the data, and then you can get the data completely. Okay. So if you see on the packet analyzer, as you can see, with the packet analyzer, you can see this is the window size, and then this is the time. Okay, so there is a possibility that during the transmission, the window size is getting increased. Okay, so it means that the window size is changed, start from 1, and then by the time goes, it increased gradually from 1, and then become higher and higher. Okay, and then if there is a time where missing acknowledgement happens, and then it start again from the beginning. Okay, so as you can see, this is a window size 1, for example, 2, 3, 4, and then we have something in when we increase 4, and then we start from lower window size again. Okay, so it looks like a saw. Yeah, started from lower number. So it's in network we call it slow start. Okay, so start again from 1, 2, 3, 4. If 4 is when we send 4 window size, okay, window size 4, scale factor of 4, and then something happened here, it means that the network is not efficient enough to send the data with the scale factor of 4. So it means that I have to decrease the window size. Okay, so that's how the TCP looks like. And then let's talk about the QoS. So when you have a network, and then how can you make sure your network is okay? So there are several parameters here you can use for checking the network. First is the latency, aka delay or round trip time, and then we can see it from ping, okay, how many milliseconds. And then you have a jitter, so it means that the variance of the latency, okay. So if the latency is keep on 26 in this sample, 26, 27, 25. So the difference between them is just only 1 millisecond. So the jitter will be 1 millisecond. And the next thing that is most important is the bandwidth, right? And then here you can check the bandwidth for download and upload. Okay, so bandwidth means how many transferred information received by the end device. Okay, so represented by bit, how many bits you already receive, okay, in 1 second. Okay, so that's the commodity. Okay, a commodity is things that what people sell or buy. Okay, so you're buying something because you see the bandwidth, right? Let's say you pay when I was in Australia, the pay is around 50, no, not 50, maybe $20 per month, okay? And then you get things like 20 Mbps, right? Of course, there will be a limit or a volume, the quota that you can download every month, okay? So, yeah, the bandwidth here is the things that people care about, okay? Usually it's measured with bit per second, and then you have to make sure that you get what you pay. Okay, so people are really complain when they are dealing with these things. Okay, so this parameter above here, the delay, jitter, and bandwidth shows the quality of your network service. Okay, so you are ISP, and then you are selling bandwidth, and then these three things are people are checking on your network to determine whether your network is okay or not. Okay, especially the bandwidth. Okay, people are really crazy about the bandwidth. Oh, okay, I already get 100 Mbps, but I just only have 70 Mbps. Okay, so yeah, that's we are here. So, so previously you already know about the parameters, how people see your network, whether your network is okay or not, right? Oh, bandwidth, the what is it? Speed test. Okay, it is a very popular way to check your network. They just check ping and then jitter and then bandwidth. That's it. That's all. Okay, so they just check those parameters. So in order to manage your um, healthiness of your network, we need to have a bandwidth management. Why? Because bandwidth is finite. Yeah. Again, bandwidth management is a process for measuring, controlling a traffic. Okay. Usually, it's measured on in bit per second or BPS. As you can say, kilobit per second, megabit per second, gigabit per second, terabyte per second, or whatever. Uh, Bandwidth management or QoS is sometimes is known as a traffic shaper or bandwidth limiter, QoS, and etc. etc. So what we expect after implementing the bandwidth management is avoiding the link is full or congested. Okay, manage a fair share of bandwidth for a customer. So make sure that they get the bandwidth. And then there is a possibility to share the bandwidth among the user equally, okay, as based on their priority. Okay, so when we talk about bandwidth management, we are not talking about the limiting the bandwidth, the bit rate, but if they have higher priority and then yeah, that can be applied as well. Okay, so this is important. Okay, so when you buy a package from your GSM network from telco provider, and then they must have a QoS to make sure that there is no user dominating the bandwidth. Okay, but there is a possibility that, so when I was in a campus, so we have a local network, so it's nothing to do with the ISP. So you have a switch. At that time, we still use 100 Mbps. At that time, is maybe in 2000s. And then I have a server here, server. And then here is 100. All of them are 100 Mbps. And then we have a client here, client here, client here, client here. Okay. So this is 100, and this is also 100. And then all of them are accessing the server at the same time. Why? Because it's a file server. There are a lot of things on there. You can find a movie, you can find an ebook, you can find a data set, many things, okay? So it's a file server where people are accessing. So what happened at the time? The server gets busy, and then this link is saturated. So yeah. So as you can see, this is 100, this is 100, everything is 100. So, and then we have problem with the bandwidth. Okay, so that's why we need to set up a QoS. Actually, this problem can be solved because this is a switch usually for aggregated link. The port here usually has higher capacity compared to others because it's aggregating the bandwidth. So instead of 100, the aggregated port can have 1 Gbps, okay, while others are still 100 Mbps. But still the same problem. If many people are accessing a server at the same time, again, you're reaching your capacity and then you have a bandwidth problem. Okay, so that's what happens. So it means that, yeah, we need to have such a way to make sure that there is no customer, particular customer dominating the bandwidth. So yeah, yeah, it doesn't matter if you are the first one who is accessing the server, but because we have a QoS, your bandwidth needs to be shared with others. Okay, so with the QoS model, we have two types. First is int-serve, integrated service, or diff-serve, or differential service. The difference between them are here. If we use int-serve, the application needs to reserve the bandwidth first. Okay, so it's similar to like circuit switch, yeah, CS, circuit switch. Okay, so circuit switch is like telco in the, yeah, telco now is using packet switch, but previously they are using a circuit switch. So it means that when you want to make a call, you need to reserve a bandwidth or dedicated lines end to end from source to the destination. Okay, so for example, you have an exchange here, you have another exchange, okay, another exchange, and then this exchange has a trunk. Okay, uh, this is A, this is B. Okay, so you need to reserve a cable. Okay, so I'll be using different colors. So you need to reserve a cable from here to here, from here and here. Okay, so the cable here is reserved. So it's similar like in-serve. So this kind of implementation is similar to in-serve. If we are using packet, a packet switch, or yeah, like what we are doing, yeah, packet switch. So with the IP-based network, yeah, there will be a signaling required for doing that operation. So here in terms of signaling, okay, signaling, in-serve requires a special signaling mechanism, for example, RSVP, reservation protocol. Okay, so you need to reserve that. But for diff search, which you can use a packet marking. So we just mark the packets, and then the packet will go to queue. Some examples is for in-serve is MPLS-DE. I think this is a good topic. It's a fun topic, but perhaps people want to discuss about that. What's the benefit of traffic engineering? So traffic engineering, as you can see, is similar to like this case. So you are reserving from end to end. Okay. While on diff service, we just use queue based on the packet marking. So we do the marking first, okay, here. And after we mark the packets, and then we put in the queue, and then depends on the settings on the queue, and then the packet will be released from the queue. Okay, guys, if you have any questions, and then just write something on the group chat here. Okay. I can see some of you are typing something. That most of them are for introduction. Okay, thank you for coming. Right, so let's continue then. Oops. Yeah, now let's talk about queuing theory. So when we talk about QoS or queue or whatever, so you like it or not, you'll be dealing with this queuing theory. Yeah, I learned this queuing theory when I studied, and then it's still petrified in my memories. Yeah, I learned this one when I took in the beginning, in early 2000s. I learned first time the queuing theory from operation research, and then one of the topic is queuing. Okay, and then when I continue my study, I learn again this thing. So it reminds me when I was studying. Okay, but anyway, when we implement the queue, okay, so when we do the model, we can model the phenomena, the mechanism into a model like this. Okay, so you have a rival here. So this queuing theory is not only be applied on routers or routers, or a QoS server, but this can be applied on, for example, in the beginning, queuing theory is applied on telco. Okay, telco. How is it possible to be applied in telco? So you have clients, okay, and then they are connecting to exchange, and then they are connecting to exchange, and then here's the destination. Okay, and then here we have trunks. Okay, and then people are doing like this. So you're calling from here, and then this is the destination. This is the source, and then here's the destination. Okay, so the problem is how many trunks line do you need to provide from city A to B? Okay, so that when the total number of clients call, it can go through D. Okay, so that's the benefit of learning the queuing theory. So the capacity planning, yeah. So queuing theory will lead to capacity planning. What capacity do you need in order to make this happen? Okay, and then there will be a probability, and then so if you want to wait, so when the all trunk is full, and then the customer has to wait, right? Yeah. So so usually it is applies on peak hour. Okay. Yeah, again, how many trunks line do you need to provide from A to B so that the client doesn't have to wait for example, 1 minute, for example. Okay. Another example is, in our router here. So the model for queuing theory is you have arrivals. Sorry, back to the example implementation of queuing theory. First is telco. Second is call center. Okay, so you want to call somebody when you want to make a complaint, right? Or you want to activate something. So usually the company provide call center, and then the big question is how many agents do I have to provide for a peak hour? Okay, so for that one, to answer the questions, you need to one model to solve the problem is by using queuing theory. So queuing theory has several components here. First is the arrival, and then you have queue, and then you have server, and then this is the departure or release. So arrivals is like call. Okay, so I'm talking about the call, customer call. Okay, so that is arrival, and then this is the server, or in our case, this is a call center. Okay, agent. Okay, if the total number of agent is higher than or the is higher or is higher than the call, and then there will be no queue, right? Okay, but if the agent is for example, you only have 2 agents, and then incoming call is 3. Okay, so 1, 2, 3. So, and then you have 2 agents here. Okay, so first will be handled by this, second will be handled by this, and then the third one will be queued. Okay, so you have to wait until one agent is free, and then pick up your call. Okay, so that's the idea of how we representing the problem. So lambda arrival here is represented by lambda. It follows a what is it? A statistical distribution. Either you have Poisson distribution or I forgot the other one. And then here is the server is also represented by mu. Okay, and then here's the waiting area, or usually we have a unit of millisecond. How many millisecond we have to wait for that? Okay, so that's the idea of the queuing theory. Uh, Before we go further, so I think this is important because, you like it or not, we always queuing our packets in the router. About the queuing type on Mikrotik, okay, let's talk about the implementation on QoS implementation on Mikrotik. So the implementation is using HTB, hierarchical token bucket. And then with the hierarchical token bucket here, it allows us to have a parent and then child. This is parent and this is child, okay. Steps to create the HTB, as I said, you need to have a marking, okay. And then create the policy and then apply the policy. Okay, so as simple as that. And as I said, parent or inner queue, okay, is used for, this is on Mikrotik, okay, so this is used for traffic distribution, okay. So there is no, so the actual queue is happens on leaf, okay, so this is leaf and this is parent, okay, this is parent, and this is leaf here. Okay, so the actual queue is happening here, and you have, if for the parents, it's only for traffic distribution. It's not actually queuing the packets. Right. So QoS on Mikrotik, this is what it happens. Okay, so you have an arrival. Okay, arrival. Okay, this is a big server. Okay, not a big router. Okay, router. Okay, and that router you have an interface. Okay, interface ether one. Okay, on ether one you have an arrival here. Okay, and then that arrival is processed. You have lots of packets because we are doing layer three. Layer three is packets, right? And then there will be a classifier. So classifiers just for classifying, just for grouping. Okay. After this classifier, you can use classifier depends on marking, depends on the IP address, IP address and port, other type of classifier. And after a classifier, and then the package will be queued. Okay. And then here is the real queue. Okay. So for example, depends on you, depends on your packet. So this classifier, for example, VoIP. Okay. VoIP is priority one, for example, is in here P1 priority one, and then maximum is, for example, 10 Mbps. Yes. Okay. Next is browsing. And then this is priority, for example, 5, and then maximum is 10 Mbps. Okay, Mbps. Yeah. Yeah, and so on and so forth. So this is how you do the QoS process happen on Mikrotik. Okay, arrival packets. Okay, so packet is count per second. Okay, so yes, so all packets coming in 1 second. Okay, so all packets will be here. Packets, packets, packet, 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 packet. Packets arrive, and then the router, the Mikrotik router will check those packets that is arrive per second. Okay, and then check and then classify them. Okay, you go here, you go there, you go there. This packet goes here, this packet goes there. Okay, and then after that there will be queuing based on those queue. So what about queue type? Yeah, we have some queue types here. First is Fifo. This is uh, very simple queuing. So actually, the thing that we are discussing about here is on the queue here. Okay, queue type. So the way we serve to the server, it depends on the queue type here. Okay. So is it possible to have a queue and then another queue? Yes, it's possible. Yeah. So you have a queue here. Okay, and then from this queue you go to another queue. Yeah, it is possible. Okay. So the algorithm here. So we're talking about an algorithm in the queue. So first algorithm is very the first algorithm here is very simple. That is the FIFO. Yeah, FIFO means first in, first out. Okay, it's very simple, very natural. You have a box, and then the packets arrive, and then packets out, and then here inside you have queue. Very simple. So packet number one coming, and then that's the first packet that is comes out. Packet number two will be comes later. Okay, so first is PFIFO, means packet FIFO. So it is very simple, less CPU usage. Okay, so this is very simple. The first packet will be the first packet arrive will be the first packet coming out. Okay, if the size here is rich, for example, the queue here is 5 Mbps. Okay, 5 Mbps. So packet coming. packets coming, for example, 7 Mbps. And then the queue here is 5 Mbps. And then the output will be 5 Mbps. So what about the 2 megabit per the 2 Mbps? 2 Mbps. There will be drop. Okay, here is drop. Why? Because our capacity is 5 Mbps. Okay, so 2 Mbps will be dropped. Okay, understand that that is a very simple, uh, mechanism for QoS. Okay, first in, first out. Others is, so the question is, I have 7 Mbps. Okay, this is bit, right? And then how many packets? Well, that depends. That depends. Okay. Uh, that depends. So that's why here is that's why you need to understand the process of encapsulation, right? When we receive layer 2 frame, and then the frame will be open, and then you will get the data that is coming from upper layer, and then usually we call them as MTU, maximum transmission size, maximum transmission unit. Sorry. So that depends. The MTU can be from, I forgot the lowest number, I think 48 to 1,500. Okay, so that's the MTU. So that you can divide them like 7 million bit divided by 1,500 bytes. Okay, so this is bytes. And then you can calculate how many packets arrive. You can just take an average. Okay, so that's how it works. So with Fifo, okay, packet Fifo, the one that we queuing is the packets. Okay, so it doesn't matter how big the packets, as long as you come and then you go out. A second variation of Fifo is bytes. Okay, so we are not talking about the packets anymore. We are checking in the bytes. So there is a buffer for packets to fit the bytes of Fifo. Okay, so the first byte coming, and then the first byte will be coming out. So because we are requiring more advance here compared to the previous one, this one requires more processing. Okay, so for lower router, so I suggest you to just use the packet Fifo. Next is multiple queue here. This is for multiple core, of course, with the driver. Okay, so to make sure that the driver supports the MQ50. Next is RED, random early detection. So this is how the parameters when you define the RED. Okay, kind is RED here, random early detection, which is here. Okay, is RED, and these are the parameters. So unlike Fifo, so this is the QoS. Okay, packets out, packets in. Okay, arrival and then output. So the packets will be dropped. This is Fifo, okay, Fifo. So packets will be dropped. For example, the limit here is 5 Mbps. Okay, so it's a bit low here. So the packet will start, sorry, not the packets, the system or the QoS or the, okay, you can say QoS, yeah, QoS application. So you start drop when the usage is 5 Mbps. Okay. Yeah. But for RED, we don't have to wait 5 Mbps. We can start dropping from let's say 2 Mbps until 5 Mbps. Okay, so that's why here is the maximum threshold and the minimum threshold. Okay, so that's the packets. Okay. Okay, so we don't have to wait 5 Mbps to drop. Starting from 2 Mbps, we start dropping. Okay, so that's why it's called random early detection. So there will be, as you can see, this is the minimum, and then here's the maximum. Okay, if the packet reaches the maximum, of course, there will be a probability of drop, PD, probability of drop of 1. 1 means, of course, it will be drop. So it's surely drop. Okay. But if the average Q, okay, if the average Q is less than the maximum threshold here, and then yeah, maybe 50%, between 0 and 50%, some packets will be dropped. Okay, this is useful for TCP traffic because, as I explained previously, TCP has a window size mechanism where people um, where it can be used uh, to tune the way we transfer data through the network using the TCP. So this red, I think, is really suitable for TCP traffic. Okay. Next is SFQ, stochastic fairness queuing. Well, this one first, as I said, in Mikrotik, you need to have a classifier, okay? And then the way SFQ make a classifier based on 4 options, which are source address, destination address, source port, and destination port. I was talking about the bandwidth management in Mikrotik user meeting Malaysia 2019, if I'm not mistaken. Yeah, I was talking about the classifier of bandwidth management. So when they are doing classification, yeah, they classify. Okay, so after they classify, and then they put a hash on it, and then they are have a round robin to make sure that all connection will have the same share of bandwidth. Okay. Yeah. So perturb here means is per second. So every perturb means a parameter where you are doing the hash algorithm. So every 5 seconds, the computer will doing hash of each classifier. Okay, so they identify a classification. Okay, so this is the source address, a destination address, port, and a destination port. Okay, all of them will be combined, and then it will set up a classification. And then the way we set up a classification is on these parameters. And then we have a lot. A lot means a bytes that is used for queuing the data. Okay, so it's the buffer. The whole SFQ can contain 128 packets, and then there are 1024 substream. Substream means subqueue. So it is like this. Okay, so incoming data flow, and then we have a classifier, and then each classifier will become a substream. Okay, and then all of this substream will be considered as one stream or one queue. Well, the problem here is when you use SFQ, if some client they're opening many connections, of course the 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 the, the router will allocate those allocation for those router, okay, because those clients, because the more connection you have, okay, the more connections, or the more a probability for you to get more traffic on that QoS system. So that's the SFQ. What happened if you use SFQ? Okay, so you have to anticipate if there is a client that opens many connections. Okay, all right, like torrent, for example. If you use torrent, and then torrent application will open many connections, right? And then I think this is not enough for, I mean, not suitable for that kind of situations. Next is the PCQ. Okay, so this is my favorite, but depends on the situations. I will not use it if the traffic is high. uh, this is the parameters. Okay, PCQ means per connection queue. Okay, and then here is the PCQ, and then here is the parameters. So it's flexible. Classifier is flexible. Either, yeah, uh, either you can use source address only, or port only, or destination address only in this case. Okay, or you can take all of them. Okay, it's like SFQ. Okay, for SFQ, everything is on. Okay, for SFQ. Okay, because SFQ is using all of them: source address, destination port. So that's the thing that I don't like from SFQ, because it uses all of them. Uh, yeah, for PCQ, it's more flexible. It's up to us. We can classify based on the IP address, or based on source address. So it's up to us. Yeah, it's possible. So the thing here is it's possible to uh, define the rate. Okay, PCQ rate here. Okay, so it means that, for example, we have a PCQ of 10 Mbps. Okay, 10 Mbps, but we put 1 Mbps rate here. It means that every customer, or every queue, maximum they will get is 1 Mbps. Okay, even though if we have a 10 Mbps. So if we put here 0, it means that the substream will be divide the traffic equally. So this is the nice thing. Okay, if we have 10 Mbps, and then there is uh, there is only one client in the network, and then that client will use the whole 10 Mbps. If there are two clients, and then each client will get 5 Mbps, 5 Mbps, so divided by 2. If there are 4, and then divided by 4, 5 phone lines, 5 clients, it means divided by 5. However, this PCQ requires CPU usage. Okay, it requires it requires well, a good machine to do the PCQ. This is the example. Okay, so as you can see, most of the CPU are mostly 100%. Okay, so this is on CCR 1072. 1072. Okay, 1072, and then most of the core are 100%. It's crazy, man. That's where we try PCQ on CCR. Okay, so it's not recommended if you have a high traffic. Okay, uh, well, if you use x86, perhaps because the CPU processing is higher, perhaps you can support the PCQ. Otherwise, you can use the Fifo. Fifo is much better. PCQ is very flexible. I like it a lot, but it requires CPU usage. That's the drawback of PCQ. I like it. I like it a lot. Okay, next. Oh, practice. I think. Well, we can how can we do practice here? You can practice yourself, perhaps. Uh, Preparations. Perhaps I can show you some settings. Yeah, so we're done today. Perhaps I can display some settings here. Okay, Q&A. If you have any questions, please say something on group chat, or you can turn on your microphone to say something on these topics. Come on, guys. Okay, let me share my Winbox here. So this Winbox is, okay, can you see my screen? Ah, yes. Yeah, so this is an example. So queue types, and then you can add here, then you can choose the name and then kind. Actually, in first, I'm using version 7, 7.1. Here's the latest one. And then when you see here, it's not only FIFO, RED, SFQ, and PCQ. They already put other model kind of queue, like cake here, Codel. I'm not sure what it is. They haven't introduced the queue to us. Perhaps later. Okay, so they added 3 new kind of queuing system, like Cake, Codel, and FQ Codel. We'll be discussing this one later. What's the difference between them, and then in which situations will be appropriate for them. Okay. Right. Any questions? For your information, yeah, we'll be uploading the recording on YouTube on our channel. You can just subscribe, but it takes time to do editing and then all the stuff. Slides will be available on SlideShare. Yeah, what else? If you're interested, we have classes, networking class on our website. You can see the schedule there. And
Yes, I think there is one questions.
oh, one questions.
Yes, what is different between Q3 and simple queues?
Okay. So this is very, yeah. So simple queue is a two-way for defining the QoS on Mikrotik. So simple queue, as name suggests, is for simple queuing system. So what you can do is put the name here and then the target, and also you can define the queue type also here. Okay, queue type for upload. Okay, this is upload, and for download. Okay, so the classification, the classifier is based on the target. Okay, target can be IP address. But for a Q3, Qt is different. Okay, so what you have to do is you have to define the packet marks. Okay, so we are queuing based on the packet marks, as I mentioned here. Yeah, so HTTP or QoS, we need to have a mark traffic, and then one way to do marking is by using packet mark or IP address. Okay, so that's the basic difference. So for a simple queue, you can just define IP address, for example. Yeah, it's very simple. Okay, but for Q3, you have to go to IP firewall and then mangle to mark particular packets. For example, here. Okay, I have several packets. Yeah, you need to understand the way application works. What is the IP address, the port that they are using, and then based on that, you identify that applications. If you already identify the application, you are able to identify the traffic, and after that, and then you put them in the queue. All right. Anything else?
Is there any questions,
Any
guys?
questions?
Don't be shy.
All right.
It's Friday night. I don't want to.
Yes, Friday night.
Oh,
Any
I think they're
questions?
understanding.
Oh, yeah. Hopefully, you can have some enlightenment after attending this webinar. So, if you are interested, and then you can learn more in our training. Right. Oh, I have another question here. Below PCQ rate, what does that mean? Oh, PCQ rate. Yeah, yeah. Well, rate means the rate that each customer get the maximum for the sub queue, and then here's the queue size of particular queue sub queue. Sorry, and then this is the total queue size. So make sure that the total queue should not exceed this. And then because they are queue, okay, then those packets needs to be queue. And then you need to, if you are thinking critically, you need to have a question: where the packet is queued? Where is the place? And the answer is in the RAM. Okay, so those packets are queued in the RAM. Okay, you know RAM, right? Random access memory, the things that you buy from the computer shop. I have 2 gigabit RAM. I have 5 gigabit RAM, and so on and so forth. So that's the yeah, that's the place where the package is queued. And then you have a burst rate here. Okay, burst rate, burst threshold. So these parameters we already discussed. And then here's the classifier. Okay, so the classifier is classified based on these parameters, either destination address only, destination address and source address only, or all of them. And then on each IP address, if we base our uh, classifier based on the IP address, and then here's the mask. Okay, so it means that if we use 32, it means that we are picking particular IP address /32 for our queue. Okay, so hopefully that answered questions. Who was asking? Saputra. Okay. Okay, guys, anything else? It's already 8:38 now, 20:38. It's time for pictures. Yes?
Yes, please.
Okay,
Yes,
guys, so
please.
please
For
turn on
recommendation.
your camera, and then,
And can you please
yeah, and
stop
then
sharing?
we'll take a photo on our webinar here. So please turn on.
Stop
Okay.
sharing first, please. Maybe.
Oh, stop sharing. Yeah, yeah, yeah.
Yeah. The screen. Then yeah.
So I can see
Anybody
everybody.
here? Wow, cool.
Wow. Yeah.
So 51 people here
51.
who wants to
Right.
gain their skill and knowledge. It's been great time. Again
Okay,
one.
so I'll count 1, 2, 3. Okay, and then please smile. 1, 2, 3, smile.
Mr. Nicola, where are you?
1, 2, 3,
Don't be shy.
smile. Okay, next page. 1, 2, 3, smiles. Okay. Okay, thumbs up, guys. Thumbs up. 1, 2, 3. Right, great. 1, 2, 3 for next page. Okay, good. Thank you everyone.
I think one questions. What impact does the type of view have on bandwidth management? One more question, I think.
Oh, okay. What impact type of queue on bandwidth management? Well, the purpose for bandwidth management is to Okay, let me share my screen here. Well, the purpose for bandwidth management is to achieve this one here, right? So make sure that there is no person dominating the bandwidth. And then the impact of each queuing type is this. If that depends on the queuing you are choosing. For example, if you use PCQ, you got to be careful with that because it really takes a CPU force. Okay, so as you can see, this is PCQ, and then as you can see, this is after PCQ, everything goes almost 100%. And because it's almost 100%, the customer will experience some packets drop. The connection is very slow, and then they are complaining. Okay, and then if people are complaining, that is not good for business. Okay, agree? Yes. So that's the impact. Okay, so you better be careful. So I would say better if you stay on FIFO. Okay, if you have a horsepower for bandwidth management, you can use this PCQ. Okay, it's very nice. Or you can do some programming to manage the FIFO. All right, anything else?
I think
That's
we
all.
are almost running out of time.
Yeah, we're almost running out of time. Well, guys,
Yes.
so I think that's all for tonight. Again, thank you very much. Thank you very much for coming here. Thank you very much for, what is it? Thank you very much for your questions, your photo, okay?
Yes.
And
It's
then,
been a great time as well.
yeah,
And then Mas
true.
Ahmad, thank you very much for your sharing.
And then
Oh, please.
don't forget to, I think, feedback. Okay, so I put the link over there. Feedback. If you have more topics for or suggested topics for the next webinar, you can write them there. Okay, that's all. Thank you very much, and then have a nice day.
Thank
See you
Bye.
you.
next week.
Yeah, thank you and bye.
Thank you. Bye.
Bye.
Okay, bye.